Ladies and gentlemen, my name is Stéphane Terault, and I run my own market research boutique. So I am an industry analyst, telecom industry analyst. I've been in telecommunications for 35 years. Started my career at Alcatel R&D lab, which is now known in France as Nokia Bell Labs, so small world, then became an analyst. I mean, if you remember Infonetics Research or IHS Market, the big firm that is now part of S&P, that's where I'm from. So I've been tracking base stations since the beginning of this century, base stations, antennas, radio units, all the way from access to core networks, which is interesting because we didn't talk about core networks that much since yesterday, since the start. Maybe, there is no need for a new core network, in 6G. But one thing for sure, we need chips, right? Microelectronics and chipsets, because without that, we won't do anything. And this is exactly what the theme of this session is. It's very Euro-centric, and there must be a reason for that. If you look at what's going on in the world, there is a, how can we say, kind of reshoring. We learned, from the pandemic that it was not so good to have the chips manufactured in one location, right? That created a major supply chain issues that had a ripple effect on the pricing of the base station, 5G base stations, which inflated actually the value of the market. Again, that's what I'm doing. I do a lot of quants, but also qualitative analysis. So we saw things we've never seen before in mobile infrastructure with 20% growth year over year, between 2019, 2020, 2020, 2021, 2021, 2022, and boom, 5G peak. A lot of money was spent, and we heard, actually, can we make some money out of this? We have a big problem, but the market should have never grown that fast and that much. This is because of supply chain issues. So now how do you fix that? I said we see some reshoring investment, and in fact, it's on November the 30th, 2023, very recently, the European Commission launched the Chips Joint Undertaking, Chips JU. That's the code name, right? To reinforce the European semiconductor ecosystem and Europe's technological leadership. That raises two questions that we'll be tackling, during the panel. One is, what is the state of Europe's semiconductor ecosystem, right? The second question is, what is the state of Europe's technological leadership? Now, talking about money, so the EC is putting 1.67 billion euros on the table. Member states are expecting, are expected to match to secure it all of what 3.3 billion euros. Okay, where are we? Since November last year on that front, where is the money? Is it matched already? But then, when you think about what's going on elsewhere, this looks pale, actually, because look, if you look at the US Chips Act passed in August 2022, during the peak of 5G deployments, they put a $53 billion package on the table, and they are just, distributing the grants, like it's, for example, TSMC, is going to invest $65 billion in the US in 3 fab, and they got $6.6 billion from that grant, from that $53 billion package. So this is where we are, ladies and gentlemen. So in order to kick off this panel, I propose to have Jari Kinaret go first to actually show us what it is the European Commission is trying to achieve here. And then we'll tackle, the reason why. So please, Jari. the stage is yours.
Thank you very much for the invitation to come here. Like many of you, I also come from Oulu. It's just that my trip took a little longer, about 37 years to get back here. But you know, it's worth it. Chips Joint Undertaking. I should start with a warning that I sort of misunderstood how much time I have. So I have a lot of slides, but I have to do sampling. And then from the sample, you have to reconstruct the entire presentation. But that I think is business as usual for many of you. So the Chips Joint Undertaking is a joint venture between the European Commission, European industries, and EU member states, plus 5 other countries. So we are actually a company in Finnish yhteisyritys, which is, to those of you who speak Finnish, easier to understand the word joint undertaking. Gemeinsames Unternehmen or gemeinsames Företag, if you prefer. So the English is actually, I think, the most trickiest one. So we act pretty much like the European Commission under the same kind of rules. But there are some differences. And like it was mentioned, the CHIPS Act entered force on September 21st, if I remember right. And what we do is that we implement a big part of the first pillar of the European CHIPS Act, which is called Chips for Europe initiative. Altogether, the CHIPS Act is, if I remember correctly, about 43 billion euros, which is more or less, give or take a few percent, more or less the same as the US CHIPS Act. But there are some differences. So our joint undertaking is responsible for the initiative on the infrastructure building together with EU's research programs. So what do we actually do? Well, we have a history. There have been other joint undertakings before us that have invested quite broadly on electronic components and systems, and we continue that work. In addition, we have these new tasks that we got from the CHIPS Act, which have to do with pilot lines, with other big initiatives like a design platform and national competence centers. So the countries that are involved in our joint undertaking are all EU member states, the dark blue, then Iceland and Norway as members of the European Economic Area, and then 3 associated countries, Turkey, Israel, and since about a month, the United Kingdom. A lot of things that I talk about, you can find more information on our webpage, which we are currently updating. So some things may occasionally, work a little slow or not at all, but we are working on it right now. In terms of money flow, we get money from the Commission for 2 different things. First, the activities that are not mentioned in the Chips for Europe initiative. That's the broad electronic components and systems activities, and then activities that are covered in the CHIPS Act. And they come in 2 different kinds. There are research and innovation activities and capacity building activities. And all these different wallets, we can't mix them. So there are fixed boundaries. Altogether, they add up to about 4.175 billion euros. But because of the way we function, is that if we put €1 to a project, we expect that a member state will put €1 in the project, and we expect that the industry participating in the project will put €1. So with our 4.1 billion, we actually control an overall funding flow of about 11 billion euros. So I could, if there are representatives of the funding agencies, I could tell why this is a particularly good deal for the funding agencies, but I think maybe they are not so much here. So everything that we do has to be based on our strategic research and innovation agenda, which is produced by the European industry associations that are represented in our board. This is a document that you can find on the web. It's a very extensive document. Until last year, you could get it as a PDF, and the PDF was like 640 pages. Now it's no longer accessible as a PDF, but it has been increased. So if it were a PDF, it would probably be something like 700 pages. And it has a structure so that there are some, okay, let's try that one. There are some sort of general aspects. They're sort of very fundamental things related to process technology and so on. Then there are some cross-cutting areas, connectivity and so on. And there are a number of application domains that we address. So this is very, very broad. And then there are things that are a little too far in the future for the industry to have a very good idea, and that's in the long-term vision part. And every year we publish calls that allow you to apply for funding for anything that you find in this 700-page document. So a few examples of what we do. The first example has to do with computing. Like it was mentioned by the chairman, you know, chips are crucial for computing, any kind of computing. How did you compute before you had chips? Anybody knows how to operate this thing? One, about 5 people. Excellent. So this is computing without chips. You can argue that this is digital computing because you operate it with your fingers, with your digits. But we have come quite a long way from there. So some of the things that we do are, for instance, new computer architectures. RISC-V is an area where we have put quite a lot of money. The latest projects in this area, we have put 27 million of a total project cost of 95 million. And there are other architectures just as such as neuromorphic computing that we also support. Then we also support software activities, artificial intelligence, edge computing, just as an example of things that we do. So something like 50% of everything that all proposals that we do have something to do with AI. It may be that they are using AI, it may be or machine learning, it may be that they are developing AI. But like I mentioned earlier, the application space is wide. We do a lot of things, for instance, having to do with Internet of Things or data centers or things for automotive industry, for medical applications, and so on and so forth. The first calls that we published when we were launched in September had to do with pilot lines. We are about to fund 4 pilot lines where we have reserved about 1.7 billion euros for that. And the member states have found about as much money themselves. That's all I'm allowed to say about them because the decisions won't be made until 23:59 today. So tomorrow you can ask more. But proposals are in the process of being evaluated. Then we have currently open calls, which close in May. So here there are calls that are on high technology readiness level and calls that are on low technology readiness level, where you can do anything that you can find in this strategic research and innovation agenda, including telecommunication. Then there are a few other smaller topics that we have singled out as topics of special interest. And for the first time ever, we have an international call now together with Korea on 2 specific topics on low TRL level, heterogeneous integration and neuromorphic computing techniques. I think I will skip this in the interest of time. And then things that we are planning for the future. And this slide I included because this is of some interest for the current company. So we are now at the early stages of planning what we are going to fund next year. And we expect that in general, it will be sort of similar, that there will be a broad call for high TRL projects. There will be a broad call for low TRL projects. There may be a few spices, focus projects. Then there is a suggestion that together with our sister or brother, if you wish, joint undertaking, where I think Ercebet was addressing this community on Tuesday. She's the executive director of the 6G SNS JU. So there is a suggestion that we might do something together in an area related to telecom or datacom. Discussion on that will take place in a few weeks. When it comes to the Chips for Europe initiative, we are at very early stages of planning. There may be additional pilot lines. There may be other things that we want to fund, and that I think is pretty much as I was prepared to do here. So we can stop here and give the word to the next speaker.
Well, big round of applause. Yes. Thank you very much, Jari. So next speaker is from the government's lab of Finland. This is Aarno, who is going to make a presentation on microelectronics in Finland. So your slides are going to be set up in a few seconds. So if you can take the stage.
Okay, so good afternoon, everybody, and also a pleasure to be here, and thank you for the invitation to be part of this event. And my background is really quite diversified. So I spent 14 years in the industry, then last 10 years as a professor at University of Oulu, working through my career, despite of many promises from my colleagues that you will never, this is never worthwhile, but working with microelectronics and wireless and the combination. And kind of the wireless has been my application. In wireless, you have several applications, medical and so forth, but from microelectronics point of view, my application has been wireless and RF. There is computing, there is memory, there is sensors and so forth. But that's my background. And then now I'm also representing Microelectronics Finland, which is now recently established network of professionals in academia and research, kind of supporting Finnish industry in education and research activities. But as I said, I have my dark side in the industry as well. So I hope that I can somehow combine these two views in this presentation as well. So if we think about the wireless, it started somewhere in the 80s, and then we realized that it's all about bulky big phones that need to be miniaturized somehow. And especially in Finland, that led to the development that we need to learn how to design RF. We now need to know how to design digital. We've ever had a major fab in Finland, and we were like 20, 30 years behind anybody else at that time. But we knew that we must do it, and I was part of that generation that started to do it in 90s, and the enablers were definitely three key ones. So the CMOS and other semiconductor technologies, chip design for those, laser-based optics in a way that we need optical cables to have the speed of transferring information when the wireless doesn't make sense. And then information theory and all that wireless communication theoretical stuff, which is kind of a main emphasis if we are speaking about the wireless. But these three enablers kind of should go hand in hand in the future as well. We kind of forgot that after 2G. In 2G, we needed to optimize the phone and the electronics and the radio system such a way that we were barely able to compute. We were barely able to do the RF at that time. Then Moore's law came. It scaled down the digital quite nicely. It didn't scale down the RF quite nicely, but there was intelligence people who learned quite a lot of things, and they were able to design better and better circuits. Although in principle, from our perspective, many of the things were getting worse. And that's how we ended up here. And then we kind of thought about that, yeah, this is becoming a commodity. Why Europe, why Finland would need any RF designers, digital designers, and so forth. Thanks to that, we are now where we are at the moment. We need Chip Act in Europe. We need Chip Act in the North America. And now we need to kind of catch up again. And that's really, we need manufacturing. That's, for example, the US strategy that I read recently is mostly related to that. Then there are 2-3 lines on the fact that, okay, somebody needs to design the chips. And my position here is, this is from my friend Kevin Chung, who is vice president of TSMC at the moment. So he presented this idea, and this is really the innovation that led us to the opportunity to do something without having heavy manufacturing in place, which then took us in the position where we are at the moment. So the manufacturing is elsewhere, design is elsewhere. And it all started with the IDMs. Long time ago in the US, TI was one of those first companies working with the integrated chips and really with the multi-transistor products. Intel, of course, was the basic example of that they did IC design, they developed their IC processes, and then after that, they were also doing wafer manufacturing and sold their products. TSMC kind of broke that scene. And now we are having 2 different industries in between. So there is the foundry and there is the fabless design. I've been through my career worked only in the fabless side, so I don't know how to do a transistor. But these guys who are doing the transistor are clever enough that they can abstract their ideas such a way that it's barely understandable for me. And I can design the next step and making them some use of it. So I'm user of a transistor. And this IC design is our side, then technology development, wafer manufacturing is coming here. Then we are having a new major thing, packaging and system integration, which is requiring a lot of intelligence at the moment as well. That's my addition to the Kevin's slides. So that we need to do, and kind of who would like to understand the system needs to understand that level, how it will be integrated. We have been talking about a lot about the energy efficiency here. Where energy is consumed, it's consumed in transistors. Every single transistor is taking that power. And I can say from the experience, you cannot take it and, okay, switch this transistor off. And that's going to make, but you are losing the signal if you're switching off the wrong transistor. So you need to work with every single transistor to optimize every single digit in the performance. And especially as our demands are getting higher, capacity is getting higher, my message back to the wireless community is that we should do standards, we should do systems that are hardware aware, and in the best case, even hardware friendly. We need to also take something back. If we need to take the manufacturing back, we need to take the design back. And from the design side, there is one thing. How many design engineers we need to fill one fab? How many companies we need to fill the one fab? So that competence, which is based on really intellectual property, is also something we need to raise. Jari was mentioning these design exercises here. And it's a very important part. We cannot forget that. We need to educate new generation of engineers to be able to capture these challenges at the same time when we are building the fabs. Because if we have fabs, but we don't have designers who can use those transistors, then we don't have the market. And that's not the purpose either. And the number of designers we need to fill the one fab can be nowadays in tens of thousands, maybe. Cannot say the number. It would be actually a nice idea to calculate at some moment of time. But that's really the case. So I'm worried about the education. I'm worried about the competencies really in the scale where we are. Many of us are saying that, yeah, basic level of education is Doctor of Science. Good masters can do that as well. But this is about the intellectual property, high level education that we need to maintain in Europe. And remember that it is a lot of hard, brutal work to make it to happen. At the same time, with the education that takes your whole career. I'm always happy to say to my students that, yeah, I'm actually a student as well after 30 years in this field. It's nice to learn new things and that continues. That's the motivation to go on. So thank you very much.
Yeah, thank you very much. And this is so powerful, what you just said. And I think, that sets the stage for a great discussion. But first, the last person who has not said a word yet is Tauno from Finland's government research lab. So if you can introduce yourself and give your perspective based on what you do every day at the VTT in this context.
Okay, thank you. I would also like to thank you for the organizers to have opportunity to be here. And so my name is Tauno Vähä-Heikkilä and I'm coming from VTT. We are a government-owned company. And basically, I would like to continue a few words what Jari also mentioned about these pilot lines and so on. And technologies that are also important for Finland and Europe. So there was some comments already at the beginning that TSMC is investing a lot to advanced CMOS fabs and like Aarno also said that there has never been this kind of huge scale manufacturing in Finland, and I don't personally believe also that in the near future we would see anything like that happening here, that we would have billions and billions of euros investments to really advance CMOS fabs here. But let's say in Finland, we have been focusing to some special technologies like photonics, radio frequency technologies, also some power electronics, 3D integration and packaging and so on. And basically, these are also technologies that we will see that in coming years, we will have more also manufacturing here in Finland. So advanced radio frequency technologies, hopefully also new power devices, so semiconductors, because in base stations you still need power amplifiers. It's not only CMOS. I think will still take some years that CMOS will solve all the technological problems. So we need gallium nitride and gallium arsenide-based technologies. Also photonics, actually photonics is becoming also more and more important in many domains. So how to combine, for example, several system on chips together. So photonics is needed there, and also in signal processing. And in Finland, we have long-term, let's say, we have several companies working with photonics components, and we see that that's also a big future possibility also for Finland and Europe. So there were these pilot lines, mentioned 4 different pilot lines, and there are Finnish organizations part of the 4 of the proposals. So in Helsinki region, Espoo, we are basically focusing the radio frequency technologies, some photonics and integration and packaging and power devices. And then Tampere region, there are lots of these photonics activities, and they are part of that proposal. So maybe tomorrow we will hear more what is happening with those. But we also see that there's it's not only this public money what is used. So we see that there are also really high interest from companies. So we are expecting now to have something between €500 million and €1 billion investments from companies to have new factories, R&D, pilot lines, and production sites in Espoo, Otanian, basically. So just to give some perspective that things are progressing, and we see that design is very important, but also we see that it's important to understand the advanced manufacturing techniques to be able to develop these technologies, let's say, to the next level. And one more thing that we see that computation in many aspects is very important. And for example, this neuromorphic computing, analog computing, it's becoming more and more important. And it's also one of the focus areas that we are doing technology development in Finland. And then in the future, quantum technologies are also important part. And let's say we are there, one of the top countries in the world working with superconductive devices. So I believe that this is also future big possibility.
Well, thank you for sharing your perspective. Yeah, it sounds like Finland is already in a very good position to show leadership in microelectronics and chipsets and everything. And so soon we'll see a Nokia baseband unit made in Finland, right? With all the components, I mean, with chips made in Finland. Not that much, no?
No,
because actually, I mean, they are
actually-
manufactured, you know, and in the factory in Oulu that is fully automated, plenty of robots there. But in order to manufacture the base stations, and I can say, you know, baseband units, I mean, if you look at Open Run, okay, let's manufacture the CU, the DU, radio units. But then the chipset are not coming, and actually we know where they are coming from. And the guys supplying, you know, the chipset, they manufacture, these chipsets are manufactured, you know, at the same place. So, so then with all the weapons you have in Finland, you know, to start with, plus this big initiative, you know, in Brussels, how well positioned is Europe, you know, to show leadership? Can we say retake some level of leadership in the world in microelectronics and semiconductor? Yeah, I mean, anyone?
Yeah, that depends on the area. So I was in the major conference ISSCC for more than 10 years, and seeing actually when the Europe was really the top-notch design part.
Yeah.
So we could be as proud as Apple was designed in Europe, designed in Finland.
Mm-hmm.
And we have started to lose that one as well. So we are not any more major factor there either. And I think the major challenge for this is that we cannot put our basket just to the manufacturing. We need to have the next level of intelligence, because it's really indeed designed in Finland is already something that we know that one of the major companies in Finland is doing. So
Yeah,
we know design in Finland, then we can think about the manufacturing a bit more differently. In European scale, definitely important, but every country cannot do everything. So I hope that Tauno will be having a successful story with the quantum. And then where the fabs are, they need to be there where it's safe to make products.
But, you know, I mean, the concept of fabless started, you know, last century when I was actually working at Alcatel.
Yeah.
I mean, and before working at Alcatel, I was in engineering school. And again, I said telecommunications. We were learning everything, you know, from, you know, radio frequency design to core networks with, you know, packets, you know, we're not there yet. So we were, you know, looking, well, and now I went back last year to give a talk, you know, at my engineering school. And I was shocked to see that, for example, a RAN course was no longer available So I was like, what are you guys doing? AI, computer science. Ah, okay. And I realized, oh, we got a problem here because, and this is exactly what you say. If we don't have IC design at home, then we're in trouble. Now bringing back, the fab is another problem. It may not be, that necessary after all, but we really need the engineers. So we need to form people. So I guess, in the schools, University of Oulu, there might be, a RF class or something, to prepare these people to, and, IC design class. I mean, where are we?
Yeah, if you take a back of the history, actually, why Europe and Finland became so strong in RF? It was partially due to the fact that the US say that analog is not needing anymore. Everything going to be digital. There is going to be the processors and so forth. And then all of a sudden the wireless rose. And then the RF engineers, we had a good time to learn it back. US schools were still in the digital side and we made it. So we needed to find the right place, right time to be. And everything matched very well then from European perspective. We got a strong foothold on that. We are having a strong foothold in automotive as well. So there's special fields.
Mm-hmm.
But as we are in the global economy, we know that we cannot maybe be the world leader in all possible fields. So one of the key items is selections as well. And if you have known something, it's much easier to be on the top and to get there. Still, we are seeing that a lot of countries have invested a lot to get there. And we remember that that's why we don't have time to waste now our efforts to really push us back to the major scene.
Yeah, in fact, when we look at what, the time frame Jari presented, it looks like it's moving fast, actually, for, a huge bureaucratic environment, if I may say.
Yeah, maybe I can comment upon that. It's quite clear that this Chips Act has resulted in much more activity than at least I expected. That it's not only the Chips Act with it's 43 billion euros, but it's many of the member states. If you start counting the various programs that countries like Germany and Portugal, and next week I think Finland, or maybe tomorrow Finland, have announced, you add up those numbers and you get to an amount that is well over 100 billion euros. So that's a very substantial investment. And we see on the sort of production side, these IPCEIs, important projects of common European interest, that have produced a lot of activity. And in Germany alone, there is ESMC, which is TSMC with the T replaced by E, and Intel building fabs. So a lot of things are happening. And I think a lot of things are happening because people really realize that the fact that there were problems in the supply lines stopped some of the most important industrial branches in Europe. You could no longer buy a car because it needed some silly chip somewhere. And that technology is one where Europe is quite strong. So we have to find ways that, like in any good engineering system, it builds resilience to the system, a redundancy perhaps. And sometimes complexity is the way to go. That I don't like the talk about value chain, because a chain is something that you remove one link and it's broken. It's much better to talk about ecosystem or value network and so on, to make sure that it's a little bit more robust structure, and that's what we need to aim at.
Yeah, actually, when you say value chain, supply chain, you made a very powerful point here. Well, this is the way, this is the result of what has been happening since the beginning of this century. of saying we design and the rest we don't care, because, you know, it's not interesting and we cannot produce the stuff, you know, at an affordable price. So let's put that, you know, somewhere else. So, and that's how you create a chain. And actually, you know, from the different blocks you showed, Arno, you still have some kind of a chain on your chart. So there is, you know, now a potential to look at how to break the chain, or maybe there is no chain if it happens on one continent like Europe or the US, because everything is there. So, you know, unless there is something very tragic, like the bridge in Baltimore, you know, that was broken, then you actually disrupt, you know, that, I mean, because this is a big disruption around Baltimore. So this is something to really look at, you know, when we think about reshoring, you know, the chipset, you know, from the design all the way to the manufacturing of the product, the final product, and selling the product. You mean you solve a problem, but then there might be other problems that need to be looked at or, you know, envisioned. And do we have any questions in the room? I don't see any. Yeah, I mean, I need a cap here. No, I don't see any. Okay, so how long do you think it's going to take for Europe to retake leadership?
Well, it's pretty clear that it's a marathon, it's not a sprint. So there is really no time when you should stop running, because, you know, the world is running around you. So if you think that you are done, that's when you are losing. So it has to be a continuous effort.
Yeah, and like if we see these big fab investments in Central Europe, I think those have been driven mainly with the automotive industry and to have this supply network available in Europe. And I think it's not only competition from technological point of view to have these fabs in Europe. It's also more like resilience and geopolitical item as well. Since the markets are growing in all segments, so there is need for more manufacturing capacity. And then if you are running out of chips, it will be also an economical problem for, let's say, companies who are really making products. So I think this resilience type of aspect is also very important from a European perspective.
Yeah, this is interesting question. Actually, this leads to this that yeah, definitely I wish not to teach politics related to the semiconductors for engineers, but politics related to the semiconductors would be very excellent item in economic schools in otherwise, because the resilience is always a cost. And we know that part of this story is that engineers has been so competent and capable that the prices of individual chips have gone down. This is really a mass market at its best. So the engineering effort that you need to put to sell one chip is huge if it is the highest level of competence. And the other aspect of this resilience is indeed that we are having a few hundred of, let's say, manufacturing capabilities all over the world, but it can be only one fab, earthquake, anything that will destroy the capability for a long time. I was working in the Japanese company, not working with that fab, but when the major earthquake in Japan happened some 10 years ago, and that impacted the whole company. That didn't impact the whole world because that was not the most important fab in the world. And that's part of the resilience that we need to have. But we always need to remember that this is also impacting the cost. And then there are two timelines. So catching up in design is a bit faster process. It's not a fast process, but it's a bit faster process. than when we are making these new manufacturing capabilities, where I'm expecting maybe that I can run my chips in 10, 20 years. Before that, I need to do my work, develop the education for what I'm having at the moment. And that's why the quarter in our economy is not 3 months. And that we should remember in Europe, because this is the biggest mistake what we could do in the future, is that now we are saying that now let's 5 years we are investing on it, and then we are happy.
Yeah, well, I mean,
it's like a raising a child.
Yeah, that brings us to, around 2030, when 5G, well, 6G is supposed to take off. And I can tell that I wouldn't be surprised to see something called 6G emerging in China in 2028. So, at the same time, it was interesting yesterday well, this was this morning or yesterday, the standard panel, no one talked about the fragmentation. I mean, we experienced a bit of that during the 5G debate, because, there are some companies involved that wanted to lead and, take over the whole thing. I mean, and in fact, it's Alex who said, the rumor is we wanted to go fast, with 5G, with all the decisions made. But anyway, I mean, it's, I mean, that also led to an acceleration of the design of some chipsets and so on. I mean, that created actually the race toward the 6 nanometer back in 2019, 2020, raising the question of whether Huawei would be able to supply all the base stations in China. And particularly for the massive MIMO, they were lacking some components. So, you have to find a plan B. So I'm talking about all the ramification of having collaboration, at the standard level, collaboration, at the IC design level, in order to make substantial progress and meet the deadlines. Because this is, I mean, when you think about it in the semiconductor industry, 5 years, that's nothing. I mean, yeah, we are with those big budgets on the table here and in the US. But then by 2030, we want to see lots of things out of those initiatives, right? So are you confident that it's going to happen?
There's a question.
There is a question in the room right here. Thank you because I was not looking at this.
Thank you. I'm a Meri Helle, semiconductor entrepreneur, and I would like to ask a question about the people flow or pipeline, how to start building. And to give a little bit of background, I'm from Finland in the Helsinki area. I've been collaborating with Swedish sometime, and I think the Nordic countries, they are excellent. And because of the history of Nokia and Ericsson, we now know how to build systems and work with new materials or frequencies and complicated analog and digital systems. But where to start, and maybe to put the present situation, I have understood that the current system on chip design cost 750 million per chip. And it increases 50% every time you go to the next node. So we are in the point, in my understanding, that telecoms don't have any more effort to do it by themselves. Of course, they have a good chip design teams and a number of people, even if the people, they are limited. But how to enable, and I'm looking this with my Swedish and German colleagues now from the chiplets perspective, that maybe we could share some ideas and development costs and maybe some extra revenue streams between automotive and telecoms, and other industry areas may come later. And maybe chiplet is an answer to here, but how to get people educated, and how to, in addition to chip design, we have a SIP fab investment coming into Tampere, hopefully getting the successful results today, in addition to Oulu. And Oulu, we have RF Valley. In Tampere, we have the Laser Valley. And in Helsinki area, we have a lot of activities. But how to get the people? How to arrange the education?
That's a problem to whole Western world, actually. We've been discussing this in the major conferences now for 1 or 2 decades. And we of course know what was the US solution for that. So they've been open for talent and making talent to come where the things are getting rough and heavy and people are looking for the better life. Mm. And then if you're searching for an easier life, this is not the field to choose. And that is a bit of a problem in our Western society, I must say. It's everywhere. And we need to find the tricks and treats for that. Of course, first of all is always salary. Second one is respect. Mm. And the third one is really stability. And I think one of the things that these semiconductor areas has been missing recently is the stability. Market is so harsh, things are changing, and there are people who are willing to do that globally. So we are all the time in global economy. I was fortunate enough that I realized it when I was a university student, that I'm not going to feel that this is kind of, I cannot stay fully in Finland. So if I'm just taking my Finnish classes on, I'm going to be lost, because the world is world. And live with that and live with the conditions of that. But that has surprised actually now both North America and Europe, and that's a challenge at the moment.
It is a big challenge. I mean, when you have, again, you know, back when I was at school, people were like, why in the world am I going to study radio access networks when, you know, I can get twice the salary by having a degree about AI, you know? So AI is a bubble, it's going to burst, and then we'll go back to run with AI inside. I mean, you know, 6G will be AI native, but we'll still need radio and all that stuff, right? Radio frequency. So we have reached the end of our session. So please, a big round of applause. Oh, you have another question? Because, I mean, the next panel is waiting for us to leave the stage.
Maybe very quickly. No, I got lost. No, I forgot it. So.
Well, you can catch up, you know, right after the session. So big round of applause for our distinguished panelists.